All right, guys, so for Chapter 9, I just put together some sample problems that we could look at from each section. So Section 9.1 was the midpoint formula and the distance formula. So those are both good formulas that you should have. The midpoint formula looks like this. The new point, you take x1 plus x2, add them together, cut it in half. That takes the average of the two. And then same thing with the two y values. You add them together, cut it in half. Once you do that, you'll have the midpoint. Keep in mind it's possible to have a fraction. And then the distance formula, big square root. First set of parentheses, we subtract one x value from the other, then square it. And then plus, subtract one y value from the other, and then square it. So those are your two formulas we're going to be using during that section. Those are great things to have on your note card. Here's a couple of examples. So for midpoint, let's say I ask you to find the midpoint between -8, 6 and 3, 4. All right, it would look like this. So your midpoint is this new point. You add the two x values together and then divide by 2. Excuse me. And then you add the two y values together and divide it by 2. So we're just going to simplify these up. So -8 plus 3, that's a -5. And then you cut it in half. You can write -5 halves. You can write -2.5, -2.5, whatever you're feeling. 6 plus 4 is 10. 10 divided by 2 is 5. So that would be the point that's directly in between these 2 points. And then let's do a distance example. Let's say I ask you to find the distance between these 2 points. Now, of course, I'm just being very, very lazy here in what I'm writing down. You would have full directions like find the distance between the ordered pairs blah and blah. But I'm just being lazy right now. So d equals, again, big square root. So you subtract one x value from the other. Now, it doesn't matter if you do 10 minus 1 or if you do 1 minus 10. You're going to get the same answer. Technically, formula says x2 first, so I suppose I'll do that. But since you're squaring it, like I said, it comes out positive regardless. Plus, and then one y value minus the other. So minus a -3 becomes plus. Always be careful with that. 1 minus 10 is -9. When I square a -9, I get 81. -5 plus 3 is -2. When I square a -2, I get 4. So when I add that together, I get the square root of 85. If you wanted to, you could plug that in and get a decimal approximation. On your test, I don't care if you do a square root or a decimal. Either way is totally fine with me. Okay, so that is 9.1. For 9.2, remember, we're no longer doing all of those crazy formulas that the book has. So let me write down what you do need to know. So here's something that we call general form. And that looked like this. This is something that we did in the beginning of the year. And then standard form for a parabola looks like this. Y equals a times the quantity x minus h squared plus k. And in this chapter, we also introduced the sideways parabolas, which looked like this. Okay, so let me show you a typical type of example. You should be able to get parabolas from general form into standard form by completing the square, and then you should be able to graph them if I give them to you in standard form. So we're going to do a couple of combo problems. So first one, say I give you y equals 3x squared plus 24x minus 10. Okay, so what we're going to do is we're going to get this into standard form first, then we're going to graph it. So this piece right here, whenever you have an x squared and an x term, we see you complete the square on those terms. So the first rule of completing the square is that you cannot have anything in front of the x squared. So whatever's there, this time it's a 3, we're going to factor it out. Now note, you are not factoring out a GCF. You are just factoring out the number in front of the x squared. So we are left with this, and then I'm going to leave a space because I know that I'm going to be completing the square in just a moment, and I just push the minus 10 outside the parentheses. Okay, so now inside the set of parentheses, my middle term is an 8x. The completing the square step is I cut that middle term in half and square it. So half of 8 is 4, 4 squared is 16. Now remember, what I technically just put on here was a 16 times 3. So 16 times 3 is 48. I just added in a 48 that wasn't there before. So to balance it out, I have to subtract 48, and then it's like it never happened. Okay, so now let's clean this up even further. So I've got a 3 here. This factors down. We're trying to figure out what multiplies to 16 and adds to 8. That's 4 and 4. So this factors down to x plus 4, which we write as x plus 4 squared. And then we have a lovely minus 58 on the outside. Okay, so that's how you complete the square. Let me show you how you'd graph it. It looks like this. So first of all, the y equals means it's either right side up or upside down. The positive 3 means it's right side up. So what I do first is I plot my vertex. My vertex is negative 4, the opposite of what you see in parentheses, and then no parentheses here, so it's just negative 58. So the vertex is negative 4, negative 58. So I'm going to go, let's scale that, negative 2. So here's negative 4, and let's scale this by, like, I don't know, 10. So negative 10, 20, 30, 40, 50, 60. So negative 4, negative 58 would be right about there. And then this 3, not only does it tell you that it's right side up, it also tells you that it's vertically stretched, which is going to make it skinnier than a normal parabola. Okay, so something like that. I will provide you with grids, by the way. Okay, over here let's do an x equals. So x equals y squared plus 14y plus 20. So we're going to get that into standard form, just like this one, and then we're going to graph it. So this is an x equals, which means it's sideways. But we still take these first two terms, the y squared term and the y term, just like we did here with x squared and x. We're going to complete the square. Now, lucky for us, the y squared is already by itself, so we don't have to factor. We just need the completing the square part. So y squared plus 14y, and then we just push the plus 20 off to the side. So this term, the middle term, we start with the 14, we cut it in half, that's 7, and then we square it, and that's 49. And I just added a 49 when there didn't used to be a 49 there before. So to balance it out, I have to subtract 49. Okay, so now let's clean it up, get it into our standard form. So what multiplies to 49 and adds to 14? That would be 7 and 7. So I do y plus 7 times y plus 7, which means I can write it squared, and then minus 29. Okay, so that is our standard form. Let's graph it. So x equals means it either is a right parabola or a left parabola. I just drew those opposite, right parabola or left parabola. The fact that there's technically a positive 1 out front tells me that it opens to the right. So I find the vertex. Negative 7 is my y value. Be careful with that. It's the opposite of whatever you see in here is the y value, because there's a y here, and then this is the x value. So for my x value, I go to negative 29. So let's make this negative 10, negative 20, negative 30. And the y value is negative 7. So negative 2, 4, 6, 8. So right about there. So again, my x value is negative 29. My y value is negative 7. So that is my vertex. Again, the fact that there's technically a positive 1 here tells me that it opens up to the right. And there isn't, there's not like a 2 or a fraction or anything like that, which means it's just normal width, not stretched, not compressed, just kind of average. Okay, so that's your parabola stuff. So those are the two things you should be able to do with parabolas is get it from general form into vertex form like this, and then you should be able to sketch. Okay, next section, 9.3 was circles. So there's a couple things you should be able to do with circles. Let me write down the standard form first. Okay, so one thing to note, especially if you don't really know what something is, if you don't know if it's a parabola, don't know if it's a circle or what, notice with the parabolas, one of the variables is squared, the other one is not. One variable is squared, the other is not. With circles, both of them are squared, but this is the one where there's a number on this side, not a 1. Once it's left in standard form anyway, because sometimes the ellipses and hyperbolas, you need to change them to get a 1 on that side. So one thing you have to do is if I give you a couple of things about the circle, say for instance I tell you that the center is the point negative 1, 6, and I tell you that the radius is 3, you should be able to put that information into the equation. And this is pretty straightforward. You're basically just plugging in the center and plugging in the radius. So I plug in x minus negative 1, turns into plus a positive, and then plus y minus 6 equals, and then 3 squared would be 9. So that's it. If I give you info about the circle, that's literally all that you're doing is just kind of getting it into its form like that and plugging in all of the information. That's one thing you could have to do. Another thing you could have to do is, just like what we did up here, is getting it into standard form. So let's look at something like that. So say I give you this, something in conic form where it's just got basically all the pieces just kind of stretched out like that. So I could give you a problem like this, and I would ask you to get it into standard form, which is this form right here, and then just to practice, we'll also graph it. So what you do is, if they're not together already, group all the x stuff together, group all the y stuff together, and then anything that's just a constant, we're going to boot off to the other side. Okay? So let's start with this first thing I've got bracketed here. We're going to complete the square. There's nothing in front of the x squared, and there's nothing in front of the y squared. First of all, that's your first clue that it's a circle, if there's nothing in front of the x squared or the y squared. So with this bracket, I'm going to complete the square. So I start with my middle term, cut it in half, that's 2, square it, 2 squared is 4. So I am going to add a 4. Okay, and then over here, this negative 11, remember I would have added this to both sides. So now the 11's over here. What I just did to my left-hand side is I added a 4 that wasn't there before. So I balance it by adding a 4 to the other side. Notice there are 2 ways to balance something. You can either add it and subtract it on the same side of an equation, like we did here and here, or here and here, or you can add something to both sides to balance the equation. Different things are appropriate with different types of equations. Okay, now plus the next group, y squared minus 2y. Now I complete the square on that middle term. Negative 2, half of that is negative 1. Negative 1 squared is positive 1. And again, I just added a 1 that didn't used to be there before, so I'm going to add it over here. Okay, so I'm just a step away from having it in standard form. This first set of parentheses, I'm going to factor it down. It factors down to x plus 2x plus 2. So I write it as x plus 2 squared. Remember, the trick is this number right here is half of this number right here. Plus, so now following that trick, you've got y, half of this is negative 1 squared, equals 11 plus 4 plus 1, that gives me 16. So that is your standard form. That would be your final answer if I just asked you to get it into standard form. Next, just to practice, we're going to graph this. So this center is the opposite of what you see in both sets of parentheses. So the x value is actually a negative 2, and the y value is a positive 1. So that's my center. We're just going to mark it. It's not really a point on the circle, so I usually just put an X or a star or something there. And then 16, that's my r squared. So if r squared is 16, that means my radius is 4. You just take the square root to figure out that number. So I'm going to go 4 units in every direction. I'm going to go 4 units up, put a point right there, 4 units down, put a point right there, to the right, point there, and to the left. Okay, so now you've got your 4 points. Of course, you will have a grid in front of you, so you'll be able to make it more circular. Let's catch that one. There we go. Okay, so that would be your answer. As long as you've got the right center and the right radius, you are good to go. Okay, so that's 9.3. That's your circle stuff. Next, 9.4 was all about ellipses. Okay, so 9.4, oops, you can see right through that paper. Let's get a new one. Okay, 9.4 was ellipses. So here are your 2 equations. Now there really is not much of a difference between these 2 equations. I'll explain exactly what it is. So basically, if you just know one of these, you're fine. The only difference between these 2 equations is that the way we defined everything, like the vertices and the co-vertices and stuff, this A is supposed to be the larger of the 2. So this one would be horizontal, which means you go farther left and right than you do up and down. Here, since the A is under the Y, that means you go farther up and down than you do left and right. That's what makes it vertical. So one of the things that you will have to do is you will have to come up with the equation if I give you some information. So let's say I give you a couple of vertices. Say I give you vertices of 2, 6, and 8, 6. Okay, and then let's say I give you co-vertices of -3, 5, and -3, 1. Okay, so I've got vertices and I've got co-vertices. So what you do is, first of all, based on those vertices, you can find the center. So you can see that these two have a common y value, and then they go left and right to 2 and to 8. These ones have a common x value, and they go then they go up and down to 5 and to 1. So based on that, you'd be able to tell me the center. This common x value is the center, and then the common y value is the other half of the center. Okay, so you know that much. So you know h and you know k. So now if you look at the vertices, the 2 and the 8, that's in an x direction. That's a couple units left, a couple units right. So that makes this horizontal. So that means for this specific one, we're going to be using this equation. Okay, so here's what we have so far. We've got x minus -3 squared over something, we'll get there in a second, plus y minus 6 squared over something equals 1. That's where we're at so far. Now A is the number of units left and right from the center. Okay? Now hang on, I actually have to, let me see, I just made these points up and this did not work very well. Okay, let's try this again. Okay, I'm sorry, this is what I get for trying to just make up points on the fly. Okay, so we're good on the made-up vertices. We've got to change the made-up co-vertices. Okay, so let's try this again. So back to these. The common y value is still 6, so we're good on that. Here, the common x value is 5. I'm sorry, I really should have pulled the problem out of the book. So now this right here would be -5. Now we should be good to go. Okay, so back to what I was saying. So the vertices, we go left and right a certain number of units. So we start at 5. And then we go to the left to 2, or we go to the right to 8. So that's 3 units. So that means A is 3 units. And then if you look at this, the center of the y values is 6, so we can either go up to 8 or down to 4. So that means I'm going 2 units up and down, and that would be B. So remember, A is your number of horizontal units if you're using this formula. B is your number of vertical units if you're using this formula. The only thing that happens is they switch if you use that one. So now my formula requires an a squared down here. 3 squared is 9. And my formula requires a b squared right here. 2 squared is 4. So that would be your formula. So you'd give that as an answer if I gave you the vertices and the co-vertices. Now let's practice graphing these ellipses. Okay, so you go to the center. So the center is 5, 6. So again, we just kind of mark the center. And then left and right, remember x stuff is left and right, I go 3 units, because that's the square root of 9. So I go left 3, and I go right 3. I just did those in opposite order, but you know what I mean. And then y stuff is up and down, so I go up and down 2 units, because that's the square root of 4. So I go up 2, and I go down 2. And then I just connect the dots. You'll notice I get an ellipse that's slightly wider than it is tall. That's what makes it horizontal. That's what pointed us to this formula. So that's our ellipse. Okay, so those are the 2 types of things that you will have to do with an ellipse. Let's look at hyperbola. Okay, so 9-5. With ellipses, you could also have to change it from standard form, but I'm going to give you guys an ellipse example, so I think we will probably be good if we just look at that one. So the ellipse example looks like this. Okay, so that's in that long conic form. We're going to get it into standard form, and then we're going to graph it. Okay, so what we do first is we group up the x stuff with the y stuff. So the x stuff first, they make their own little group. Then the y stuff, they make their own little group. And then any constant like that, we're going to just subtract it away over onto the other side. This is very similar to the one we did with the circle. Okay, so in the x stuff, when we're completing the square, we cannot have anything in front of that x squared. So we're going to factor out a 9. So we're left with x squared plus 6x, leave a space so we can do the completing the square step. Next here we have a negative 4 in front of the y squared, so I'm going to factor that out. Be very careful, make sure you factor out a negative 4 from this negative 8. Leave a space, and we've got a negative 49 over here. Okay, let's carry on with our completing the square. So remember, just like the last couple examples, we start with this 6, cut it in half, that's 3, and square it, that's 9. But really that was a 9 times 9. So we just put in an 81 that wasn't there before, so we've got a balance with an 81 on the other side. Next, this, negative 2, cut it in half, that's negative 1, and then square it, and we get positive 1. But really that's 1 times negative 4. So I just put in a negative 4 that wasn't there before, so I balance out by subtracting. Okay? So keep this 9 right here. This factors down to an x plus 3 squared. Half of the 6 is 3. Minus 4, this factors to a y minus 1 squared equals, and I've got a negative 53 and a positive 81. All right, so that is going to leave me with what, 27? No, that's not right. 50, 23. Okay, why am I failing at this? Trying to find a calculator, don't have one. Okay, so 81, and this would be a negative 53, right? Come on, you can do math. Okay, 28, which doesn't seem right. Okay, mystery solved. I just have to pause the video. What I did is I took this, it was supposed to be an ellipse, I wanted it to be a hyperbola, so I changed a couple of numbers, forgot to change the rest. So this should have been a 41, so this is a 41, this is a 41, and that makes this a 36. Otherwise things were not going to turn out well. Sorry about that. So now last thing, this is a hyperbola, you can tell by the subtraction. We are going to divide everything by 36 because in its standard form, this is supposed to be a 1. So the 9 over 36 reduces down to 1 over 4. The 4 over 36 reduces to 1 over 9. So let's rewrite that one last time. So we've got x plus 3 squared over 4 minus y minus 1 squared over 9 equals 1. So that is my hyperbola. It's in standard form. I just realized I forgot to put the standard forms on here, so after I graph this, I will write those down. So here we go. Start at the center. The center is a negative 3. Positive 1. So just kind of mark it. Now because the x is first, this one is horizontal, opens to the left and to the right. So under the x I have a 4, so I go to the left and right 2 units. So those are my vertices of my hyperbola. All right, now under the y I see a 9. That means I go up and down 3. So I just put a little mark there because I'm going to use that to make my box. So down 1, 2, 3. So again, just a little mark there. Now we use these 4 points to make this box, and we're going to use the box to draw our asymptotes. So we have the box first. Now remember the asymptotes go through the corner, through the center, out the other side, just like this. Same exact thing right here. Okay, the box tells us how wide to make the hyperbola. So now it's left and right. We go along those asymptotes through the point and out the other side like that. And the exact same thing over here. There we go. That's what your graph looks like. Let me write your standard forms really quickly. So this is the standard form that I just used. This is if a parabola is horizontal, which means it looks very similar to the one that I just drew. Second form basically just switches the numerators. And this one would be vertical. So this one would open up and down. Okay, so this one looks kind of like this one looks kind of like that. Okay, so that's your hyperbola stuff. Let's switch on to 9.6 and then 9.7 really quickly. So 9.6 was the discriminant section. There's not a ton of stuff to talk about there, but I will give you a couple of formulas. So 9.6, here is your conic form. It looks like this. So anything that I gave you before you completed the square was in this form right here. Very crazy form. Most of them don't have anywhere near that number of pieces. The discriminant is the formula b squared minus 4ac. So you're pulling this a, b, and c and plugging it into this formula. Okay, so here's the discriminant stuff that you need to know. If the discriminant is less than 0, and these two things are true, if b is equal to 0 and a is equal to c, that makes it a circle. If your discriminant is just less than 0 and one of these things is not true, so let's say like other options, anything where these two things aren't true, then it's an ellipse. Remember, a circle is just a specific form of an ellipse. If the discriminant turns out to be exactly equal to 0, oops, forgot the c there. This is a parabola. And your last option is if it turns out to be greater than 0, and that makes it a hyperbola. That would be a good note card thing. Not that everything I've written down isn't, but this is definitely a good thing. So one of the things that you'll have to do is identify what it is. Okay, so let's say I give you this example. 3x squared plus 12x minus y plus 8 equals 0. Okay, so you've got to figure out what it is based on the discriminant. So b squared, there is no xy term, so that's 0 squared, minus 4. A is whatever's in front of the x squared, that's a 3 here. And then c is whatever's in front of the y squared. I don't have a y squared, so that's a 0. So this turns into 0 minus 0, which is 0, and that makes this one a parabola. Okay, so you get the idea. So you're plugging in whatever points you've got and then kind of comparing. Let's do one more really quickly. Okay, so this, I would have to move this 144 over, but we don't use f in the formula anyway, so. All right, so b squared, there is no xy again, so that's 0 squared, minus 4 times a, which is 9, times c, which is 16. So 4 times 9 is 36, 36 times 16. Of course, I don't actually have a calculator. However, 0 minus a big number, we know that's going to be less than 0. We can say that much. So it's either a circle or an ellipse. B is equal to 0, so we got that going, but A is not equal to C. So that is what makes this an ellipse rather than a circle. Okay, so those ones should be pretty quick. Let's move on to our last section. This is 9-7. Okay, so we had to solve systems of equations by both graphing the inequalities and solving the equations with either substitution or elimination. So let me show you a good method for elimination, or a good example for elimination. With this one, what I want you to notice is that they both have x squared terms, which means we can make the x squareds eliminate. So what we need to do, this is a positive 3. We need this to be a negative 3. Okay, so let's rewrite this line as negative 3x squared minus 12y equals negative 24. Okay, so now we're combining this line with this line. So the x's will cancel, x squareds, I'm sorry. And then I have a negative y squared minus 12y, they're not like terms so I can't combine them, equals negative 13. Okay, so now the first thing we're going to do is solve for y. It's a quadratic, so we want to get everything on one side. And since this is negative, let's get everything over here. So 0 equals, I would have added my y squared, added my 12y, and then I have minus 13 equals 0. Okay, so, I'm sorry, we already had the equal 0. So this is going to factor. So we've got y and y. We want to know what multiplies to negative 13 and adds to 12. That would be a positive 13 and a negative 1. So my two y values, I've got negative 13 and I've got positive 1. Okay, so that's half of my answer. Now I have to plug it in and solve for x. So let's go into this equation right here. That looks like a good one. So x squared plus 4y. If I plug this in, 4y would be a negative 52. Okay, so what I do is I add 52 to both sides. So I get x squared equals 60, and then my x values are plus and minus the square root of 60, whatever that is. Okay, so you can simplify that if you want. You don't really have to. So two ordered pairs we have so far, positive root 60, negative 13, and negative root 60, negative 13. So we got 2 so far. Next, I'm going to plug in the 1. So we have x squared, and then plus 4y means plus 4. So I'll subtract 4 from both sides. I get x squared equals 4. And lastly, square root both sides, so we get plus or minus 2. That's 2 more ordered pairs. So positive 2, positive 1, and negative 2, positive 1. So 4 total ordered pairs that we got for that system. All right, last thing, also 9-7, we are going to look at systems of inequalities. Okay, so I'll give you an example here. Let's say we had this and this. Okay, so they could be anything. We could have circles, parabolas, ellipses, hyperbolas. We had absolute value stuff and a couple homework problems. You won't have that. So this first one is a parabola. So let's get sketching here. This one is x equals, so it actually opens up to the right, and it's not shifted up, down, left, right. It's not stretched. So it's just a very simple parabola that goes right through the origin and opens to the right like that. Okay, now for the shading, you can't plug in 0, 0 because I crossed right through it. So let's check like this point right here, 1, 0. So test is 1 greater than or equal to 0 squared. And yes, it is. So what that means is we start part of our shading in here. So our answer is going to be inside the parabola. We know that for sure. Now this is actually an ellipse. The reason we know it's an ellipse and not a circle is because we have something in front of one of the terms but not in front of the other. So we're going to divide everything by 16. So we have x squared over 16. 4 over 16 reduces down to 1 over 4. So then we have y squared over 4 is less than 1. Also, we know it's an ellipse because of the addition, not subtraction. So this is centered at the origin. We go left and right 4 units. That's the square root of 16. Point here, and we go up and down 2 units. That's the square root of 4. Okay, now this is just a less than, so I dot it. Wow, dotting actually makes nice ellipses. Okay, so now let's test the center, which is at the origin. So 0 squared over 16 plus 0 squared over 4, is that less than 1? And yes, it is. That's true. So we also shade inside the ellipse. So your final answer, remember, is the overlap. So we're looking for whatever is inside the circle and also kind of, or inside the ellipse, and also kind of on this inside portion of the parabola, which ends up being this weird little cone head shape right here. So we're looking at that. Okay, so your final answer should be a shaded region. So that just about covers everything. Make sure you make a really good note card and study hard.